A steel nitrogen tank has a mass of 5.36. So this is the tare. Okay. When it's at 68 degrees Fahrenheit and 742 psi gauge, okay, we'll have to use absolute pressure, right? It has a mass of 9.83 kilograms because of the added nitrogen gas. If the gauge pressure is 347 psi and the mass of the tank is 7.15 because some nitrogen gas was released, what is its new temperature? Okay. Okay, so let's make this into kelvins. I think we need to do that, right? So 68 degrees minus 32. That gives us how much above the freezing point it is in Fahrenheit. Multiply by 5/9. We'll turn that Fahrenheit to Celsius and then add 273.15. And that is 293.15 kelvins. Okay, so we dealt with that. 742, all we have to do is add. We don't actually need to turn that into pascals. I'm just going to add an atmosphere, make it absolute psi. So 742 plus 14.7 is 756.7. And we can just use that in the combined gas law, okay? And then the new gauge pressure is 347. Let's turn that into absolute pressure. So 347 plus 14.7. Everything has to be absolute, okay? 347 plus 14.7, that's 361 psi absolute, right? So we can use this. We're going to use this. We're going to use this. That's psi absolute. Okay, now what do we have? We have to do something with the mass, because the mass is going to go in there for the moles, right? If you double the mass, you're going to double the moles. Okay. So initially, the amount of nitrogen initially, right? The initial mass of nitrogen is going to be 9.83 minus 5.36. And this is 4.47. This is just the nitrogen gas, which is what we have to use. Okay, and the final mass is going to be 7.15 minus 5.36. 7.15 minus 5.36. That's 1.79. Okay, so this is kilograms. Okay. Now let's see. I think we assume the volume stays the same for this guy. So let's see. PV over NT equals PV over NT. So I think volume stays the same, but pressure and temperature are changing and the number of moles is changing, right? So the initial pressure is, let's see, 742, which we figured out was 756.7 psi, absolute, divided by, and then the initial amount of nitrogen is 4.47. Now I know that's not the same as moles, but wouldn't I just divide that, turn it into grams, divide by roughly 28 in this case? And I do that on both sides, so I don't actually have to get moles. Okay, and then the original temperature is 293.15. Okay. And then the new pressure is 347, which we have to use this guy, right? So 361.7. The amount of nitrogen is 1.79. And then we're solving for that temperature. Oh dear. Oh dear. Okay. So let's go 361.7 times 4.47 times 293.15 divided by 1.79 divided by 756.7. And this will be a temperature in kelvins. Okay, that's kelvins, and then let's turn it into Celsius. So subtract minus 273.15 is 76.77 degrees Celsius. Okay, let's see. But we got to turn it into Fahrenheit. Okay, so that is how much it is above the freezing point, right? So multiply by 9/5, and this will give us degrees Fahrenheit above freezing. So times 9 divided by 5. It's 138 degrees above the freezing point of water in Fahrenheit, and then add 32, and I get 170. So I multiplied by 9/5. I added 32, and I got 170.2 degrees Fahrenheit. Ta-da! 170. It's 170.18657, something like that.